Hello viewers, in today's lecture we are going to study the method how to find the square root of a complex number. Viewers, in our earlier lectures we have discussed about the concept of complex numbers and the polar form of the complex number and other properties of complex numbers. Fine. So let us start with our topic, how to find the square root of a complex number. Let x plus iota y be a given complex number. Clear? And we have to find the square root of this complex number. Clear? It means we have to find the square root of this complex number, that is x plus iota y. And viewers, we know that iota square is equal to minus 1. Now the square root of x plus iota y is also a complex number of the form a plus iota b. Clear? So here we have a complex number, say z equal to x plus iota y, and we have to find the square root of z, and the square root of this complex number z is again a complex number of the type or of the form a plus iota b. Clear? Now let us square both the sides. So we get x plus iota y is equal to a plus iota b square. Clear? Now we can write it as x plus iota y is equal to a square plus I square b square plus 2 times a times iota b. Clear? Now we can write it as x plus iota y is equal to a square minus b square, because I square is equal to minus 1. So we have iota square times b square is equal to minus b square, and here we have I times 2ab. Clear? Now here we see that a square minus b square is the real part and 2ab is the imaginary part. So if we compare both the sides, and if we equate the real parts and the imaginary parts, we get x is equal to a square minus b square and y is equal to 2ab. Clear? Now here we are given this complex number and we have to find the square root of this complex number, and we have assumed that the square root of this complex number, that is x plus iota y, is a plus iota b, where a and b are real numbers, and our aim is to find the values of a and b. Clear? Now when we have squared both the sides, we arrived at these results, that is x equal to a square minus b square and y is equal to 2ab. Clear? Now here we'll make use of one more important identity which is given by a square, or we can write a square plus b square whole square is equal to a square minus b square whole square plus 2ab square. Clear? So whereas here we'll make use of this identity. Clear? Now a square plus b square whole square can be written as a square minus b square whole square plus 2 times ab whole square. Now a square minus b square is equal to x. So here we have x square, and then we have 2ab is equal to y square. Clear? And now we can write this equation as a square plus b square is equal to square root of x square plus y square. Clear? Now using this equation and this equation and this equation, clear, we have three equations here: x equal to a square minus b square, y equal to 2ab, and a square plus b square is equal to square root of x square plus y square. Clear? Now utilizing these equations, now we can find the values of a and b. Clear? Now I am taking one example to illustrate this method. Fine. Now viewers, let us find the square root of 2 plus iota 3. That is, we have to find the square root of 2 plus iota 3. Clear? Or we can write it as 2 plus 3i. Clear? So we have to find the square root of 2 plus 3i, and suppose the square root of 2 plus 3i is equal to a plus iota b. Clear? Because here we have used the fact that the square root of a complex number is a complex number. Now squaring both sides, we get 2 plus 3i is equal to a plus iota b square. Now this can be written as a square minus b square plus I times 2ab. Clear? Now comparing the real and imaginary parts on both sides, we get a square minus b square is equal to 2 and 2ab is equal to 3. Clear? Now viewers, here we'll make use of this identity, and a square plus b square whole square is equal to a square minus b square is 2. So we write it here 2 square plus, and 2 times of ab is 3. Clear? So we have 3 square. Now a square plus b square whole square is equal to 4 plus 9, which is equal to 13. Clear? And a square plus b square can be written as square root of 13. Clear? Now viewers, let us take this equation as 1, this is equation 2, and this is equation 3. Now we'll solve these two equations, that is equation 1 and equation 3. Clear? Now if we add 1 and 3, this equation and this equation, we get 2a square, because b minus b square and b square they get cancelled, so we have 2a square is equal to 2 plus square root of 13, and a square is equal to 2 plus square root of 13 divided by 2. Clear? Or we can write a is equal to square root of 2 plus square root of 13 divided by 2. Clear? Okay. Now let us subtract these two equations. That is, let us find 3 minus 1. Clear? So we'll have a square and a square get cancelled, so we have 2b square is equal to square root of 13 minus 2, and this can be written as b square is equal to square root of 13 minus 2 divided by 2. Clear? Now b can be written as b is equal to square root of 13 minus 2 divided by 2. Clear? And let us say this is equation number 5th. Clear? Now viewers, from equation 2 we see that 2 times of AB is equal to 3. Clear? Now here we have a is equal to square root of 2 plus square root of 13 divided by 2, and b is square root of 13 minus 2 divided by 2. Now here we can take the value of a as plus square root of 2 plus square root of 13 divided by 2, and the value of b is we'll take the positive sign, and we have square root of 13 minus 2 divided by 2. Clear? So the value of, when we take here we have plus minus sign, and here also we have plus minus sign. So when we take a plus and b also plus, that is plus square root of 2 plus square root of 13 divided by 2, and b as plus square root of 13 minus 2 divided by 2, then this equation is satisfied. Clear? So one pair of the values of a and b is given by these values. Clear? And if we take the negative values of a and b, then we have the another pair. That is, if we take a is equal to minus square root of 2 plus square root of 13 divided by 2, and b is minus square root of 13 minus 2 divided by 2, then we have the other pair of a and b. Clear? So therefore the square root of 2 plus 3i, the square root of 2 plus 3i can be written as a plus iota b. So if we take this pair, that is the values of a and b, then we have the square root as square root of 2 plus square root of 13 divided by 2 plus iota square root of 13 minus 2 divided by 2. Clear? So this is the first square root, and if we take this pair, then the square root is given by minus of 2 plus square root of 13 divided by 2 minus iota square root of 13 minus 2 divided by 2. Clear? So this is the other value of the square root. Clear? So if we combine both the values, then we can write that the square root of 2 plus iota 3 is equal to plus minus, and here we have square root of 2 plus square root of 13 divided by 2 plus iota, then square root of 13 minus 2 divided by 2. Clear? So this is the final square root of 2 plus iota 3. Clear? Now viewers, let us take one more example. Suppose we have to find the square root of say 3 minus 4i. Clear? Now here x is equal to 3 and y is equal to minus 4. So let the square root of 3 minus 4i is equal to a plus iota b. Clear? Now let us square both sides. So we have 3 minus 4i is equal to a plus iota b square. Clear? Now 3 minus 4i is equal to a square minus b square plus I 2ab. Clear? Now if we compare both the sides, that is, if we equate the real and imaginary parts equal, that is, the real part is 3 here, and here the real part is a square minus b square. So we have a square minus b square is equal to 3, and taking the imaginary parts on both sides, so we have 2ab is equal to minus 4. Clear? This is equal to minus 4. Now we will make use of the identity, and the identity is a square plus b square whole square is equal to a square minus b square whole square plus 2ab square. Clear? Now substituting the values of a square minus b square as 3 and 2ab as minus 4, we have a square plus b square square is equal to 3 square, and here we have minus 4 square, which is equal to 9 plus 16, that is equal to 25, and this can be written as 5 square. So where's a square plus b square square is equal to 5 square, this implies that a square plus b square is equal to 5. Now we have equation 1, 2 and 3. Clear? Now our aim is to calculate the value of a and b. Clear? So let us solve equation 1 and 3. So let us first add 1 and equation 3. So b square and b square get cancelled. A square plus a square is equal to 2a square, and we have 3 plus 5, that is equal to 8. Clear? Now a square is equal to 4 and a is equal to plus minus 2. Clear? Now if we subtract equation 1 from 3, we have a square and a square get cancelled, and we have 2b square is b square minus minus plus, and we have 2b square is equal to 5 minus 3 is equal to 2, and b square is equal to 1, and this implies that b is equal to plus minus 1. Clear? So here we have obtained the value of a as plus minus 2 that is we have a is equal to 2 and minus 2. Clear? And the value of b as 1 and minus 1. Clear? Now if we see this equation, that is equation 2, we have 2ab is equal to minus 4. Clear? So the first pair of values which satisfies this equation is a is equal to 2 and b is equal to minus 1, because 2 times minus 1 is minus 2 and minus 2 times 2 is minus 4. Clear? If we substitute these values in this equation, then this equation is satisfied. Clear? And the second pair is a is equal to minus 2 and b is equal to 1. Clear? So here we have two pairs of values of a and b. So therefore we conclude that the square root of 3 minus 4i is equal to a plus iota b. So if we take the first pair, we have 2 minus iota. Clear? And if I take the second pair, then we have minus 2 plus iota. Clear? So these are the square roots of the complex number 3 minus 4 iota. Clear? Now viewers, let us take our last example, that is to find the square root of iota. Clear? So here we have z is equal to I or iota. Clear? Now we have to find the square root of iota, and let us suppose that it is equal to a plus iota b. Now here we see that the real part of this complex number is 0. Clear? So this number is a pure imaginary number. So the square root of iota is assumed to be a plus iota b. Now squaring both sides, now we are following the same method which we have used in our previous examples. So squaring both sides, we get iota is equal to a plus iota b square. Clear? So here we have iota is equal to a square minus b square plus iota times 2ab. Clear? Now comparing the real and imaginary parts on both sides, because here we have 0 and here we have iota times 1. So we have a square minus b square is equal to 0 and 2ab is equal to 1. Clear? Because this is 0 plus iota times 1. Clear? So a square minus b square is 0 and 2ab is equal to 1. Clear? Say this is equation 1, this is equation 2, and now let us use this identity a square plus b square whole square is equal to a square minus b square is 0. So we have 0 square, and here for 2ab we have 1, so we have 1 square. So this can be written as a square plus b square whole square is equal to 1, and this can be written as a square plus b square is equal to 1. Clear? The square root of 1 and a square plus b square is equal to 1, and this is equation number 3. Clear? Now let us solve equation 1 and 3. If we add these two equations, we have 2a square is equal to 0 plus 1, that is 0 plus 1 is equal to 1, and a square is 1 over 2. This implies that a is equal to plus minus 1 over square root of 2. Clear? Now if we subtract equation 1 from this equation, that is equation 3, we have a square and a square get cancelled, and we have 2b square is equal to 1 minus 0, which is equal to 1. So this can be written as b square is equal to 1 over 2, and this implies that b is equal to plus minus 1 over square root of 2. Clear? Now let us see this equation number 2. Here we have 2ab is equal to 1, and here we have a is equal to plus minus 1 over square root of 2, and b is equal to plus minus 1 over square root of 2. So here the first pair of values, if we take a is equal to 1 over square root of 2 and b is equal to 1 over square root of 2, then this equation is satisfied. Why? Because 2 times, if we substitute a and b as 1 over square root of 2, 1 over square root of 2, we have 2 times square root of 2 multiplied square root of 2 is 1 over 2, and this is equal to 1. Clear? Similarly, if we take the other pair, then we have a is equal to minus 1 over square root of 2 and b is equal to minus 1 over square root of 2. Clear? And again this value of a and this value of b satisfies this equation 2. Clear? Now the square root of we can write it here, the square root of iota is given by a plus iota b. So if I take this pair, then we have 1 over square root of 2 plus iota times 1 over square root of 2. Clear? And if I take this pair, then we have the square root of I as minus 1 over square root of 2 minus iota 1 over square root of 2. Clear? Therefore, if we combine both the square roots, then the square root of iota can be written as plus minus we have 1 over square root of 2, 1 over square root 2, and we have 1 plus iota. Clear? So this is the square root of iota. Clear?